Speaking about supports, the most important thing linked with it is the reaction forces the support exerts on the object it is connected with. Now, the simplest method to understand these forces and detect them is by finding its restriction to motion along the three axes x, y, and z axis, both translational and rotational. To ease things out, let us consider a planar condition, meaning motion along x and y axis only. Now, if the object is connected to any type of support, its main purpose is to restrict its motion along any specific axis. Let us see in detail the different types of supports and how to determine the reaction forces exerted on the beam by these supports. Basically, there are four different types of supports: a simple support, a roller support, a pinned or a hinge joint, and a fixed support. Each of these supports have their own characteristics and exert a reaction force to help the beam remain in position. The important point to understanding the reaction forces is to check for the direction in which the motion is restricted. If the beam moves in the direction of the force applied, it means there will be no reactions in that direction. Keep in mind that you have to assume the beam is rigid and would not bend or break no matter how big the force is applied. Let us start with a simple support. In such type of supports, there are no connections as such, but the beam will be simply placed on a fixed surface. Now, according to the basic rules, when a force is applied in a downward direction, say for example a weight force, then the beam at this region will experience a normal reaction force and restrict its motion in a downward direction. If you try to move the beam in a horizontal direction, the beam may or may not move depending on the frictional coefficient of the surface. But this frictional force will have a limit to itself, which will be equal to mu times the normal reaction. If the force exceeds this value, the beam would not be restrained along horizontal direction. So a simple support will only restrict in the direction perpendicular to the surface, and that's for sure. Along horizontal direction, motion restriction is a little doubtful. The next type of support is the roller support. Now, this is also just like the simple support, except for this case, only a normal reaction force will act. The weight force will be restrained by the roller support's normal reaction. But any horizontal component of force being applied on the beam will cause a smooth horizontal motion without any restrictions. The rollers would move rotationally, helping the beam to move in a linear direction. Hence, in a roller support, only a perpendicular normal reaction force acts to restrict vertical motion. The use of such roller supports can be seen in a lot of cases, such as the traditional method of carrying heavy objects on big logs of wood, or in the modern world, an automobile or a roller skate. A hinge or a pivot joint is a very common type of joint you notice in your day-to-day life, where the structure is generally fixed, but still allowed to rotate about an axis. Consider the simplest example where you pin a paper on your board. The pin does not allow the paper to move in any direction, neither vertically nor horizontally, and this suggests that the pin generates corresponding reaction forces to stop this linear motion. But if you try to move it in a circular direction, the paper would definitely rotate about the pin. Similarly, a seesaw, where the plank can be considered as a beam. The support would not allow the plank to move in a linear direction, but if you apply some force at a distance from the pivot, a moment will be produced. Therefore, when a pivot joint is used, the only restriction it causes is for the linear motion, both along horizontal and vertical directions, but allows rotation motion. Hence, a pivot support has a horizontal and a vertical reaction force. A hinge on a door is also a similar type of support. The door would not move in a linear direction no matter how much force you apply, but a simple push at the doorknob region will rotate the door open. The final type of support is a fixed support. As the name suggests, this support does not entertain any type of motion at all. You try to move the beam and the reaction force along vertical or horizontal direction will act to restrict its linear motion like with a pivot. Now, if you try to rotate this beam by applying a moment anywhere on the beam, no rotation will take place either. This means that the fixed support not only restricts the linear but also the rotational motion of the beam. This means that the support exerts a reaction to both the forces as well as the moment and produces a corresponding force and moment in an opposite direction. A very basic example can be seen in the beams that are fixed on the walls or a pole on the ground. They do not rotate or move in any of the direction no matter how much force or torque is being applied. As already mentioned before, bending of beam has to be neglected in basic mechanics, as that will change the molecular orientation of the beam. That part is going to come later. I hope you understood how to find the reaction forces acting due to a support and will be able to find them in your daily life. Comment in the section below if any part was left unclear.